Hello, I am going to lead you through the 7-1 Day 1 worksheet. And starting with numbers 1 and 3, write the trig expression in terms of sine cosine. So basically, we're going to leave the cosine t as it is, and then rewrite tangent as sine of t over cosine of t. Just the definition of tangent in terms of sine cosine. We're multiplying, so these top and bottoms can cancel to 1, so we're left with just sine of t. Okay. Now over here with number 3, again, sine can't do anything there, sine of theta. Secant is 1 over cosine by definition. And again, making a fraction times a fraction, I get sine of theta over cosine theta, and that is the definition of tangent. Okay. Moving on here with 5 and 7, 9 as well. We're supposed to write only in terms of sine and cosine and then simplify. So again here, tangent squared is sine squared x over cosine squared x. Secant is 1 over cosine squared x. Okay, I do have a common denominator of both of these here. So I can go ahead and my common denominator is sine cosine x, or cosine x, excuse me. And then here we just do that. And this expression right here is can be defined with our Pythagorean identity from a while ago. So remember that sine squared plus cosine squared x equaled 1. And we're going to go ahead here and subtract that sine squared over. So we're going to get 1 minus sine squared x. But in this case, I have a sign switching going on here. So actually, if I switch this sign, and switch that sign, then this is actually equal to that. So what that then means is I can substitute negative cosine squared x over cosine squared x, which comes out to be negative 1. Okay. This next one here, not much we can do here with sine of u. Cotangent is cosine u over sine u. And then I have multiplied by cosine u. Again, I'm going to get sine of u plus sine of u on the bottom and cosine squared u on the top. And like I did before, I got a 1 here. So now if I get a common denominator between the two fractions, this will become sine squared u plus cosine squared u. And that is 1 from down here. And so I get 1 over sine u, which is cosecant by definition. Continuing on here, this one similar. Again, notice that we do have some fraction work as we go here. So I'm going to go ahead here. Sine of theta, secant's 1 over cosine theta minus cosine theta. In the top, if I get a common denominator of cosine theta, I get 1 minus cosine squared theta. And again, going back to this sine squared theta, let me fix that. So again, remember sine squared theta plus cosine squared theta equals 1. If I subtract this guy over, that's what I have on the top here. So then I can rewrite that as sine squared theta over cosine theta all over sine theta over 1. So again, I can do the tip and multiply. So I get that top, flip this as 1 over sine theta. I'll clear that up here. Okay. And so this cancels a 1, that changes the power to 1, so I end up with sine theta over cosine theta, and that equals tangent of theta. With number 11 here, simplify basically what we've been doing here. So again, first thing we do is kind of rewrite in terms of sine and cosine. Okay, and then common denominator. Well, let's simplify this top here. So that's going to be sine x cosine x over sine x over cosine x. These are identical. This is the same as this, so they'll reduce down to 1. Over here, the top looks to be all we can do right now. And the bottom I get 1 plus 1 over cosine y. To kind of work on that denominator part, I have to get a cosine y common denominator, which means I'll get cosine y plus 1. Okay, and again, if I go ahead and do my tip and multiply, so I get 1 plus cosine y. It's a binomial, so I want to put in parentheses, times cosine y over, these are the same, so I simply get cosine y. Continuing here with 15 and 17, again simplifying. We do have an identity here from a while ago. That can just be written as tangent squared theta. This is 1 over cosine squared. Oh, I guess it's x, not theta. Remember, tangent is sine squared over cosine squared, multiplying by the reciprocal of the denominator, so it's cosine squared x over 1. These cancel, so I'm simply left with sine squared x. 17, a little bit more work here in terms of fractions here. I get 1 plus 1 over sine x over cosine x plus cosine x over sine x, definition of cotangent. Getting common denominators in both the top and the bottom. Here I'm going to get sine x, and I'm going to get sine x plus 1. Here I'm going to get sine x in the denominator as well, and I'm going to get I think with this one, I'm just going to, I'm going to say cosine x sine x plus cosine x. These signs can cancel, and if I factor out cosine in the bottom, my top is this. If I take out a cosine x here, I get sine x plus 1. These cancel to 1, so I get 1 over cosine x equals secant x. Continue with 19. If I go ahead here and let's just get a common denominator right off the bat. So it's going to be cosine u times 1 plus sine u. That means over here I get 1 plus sine u squared, and over here I'm going to get cosine squared u. Well, let's expand that top. So get 1 plus 2 sine u plus sine squared u plus cosine squared u over this denominator that hasn't changed. I'm just going to leave it in factored form. These guys become 1, so I get 2 plus 2 sine u over cosine u, 1 plus sine u. If I factor the 2 out, I get 1 plus sine u. These cancel, so I get 2 over cosine u, or I could call that 2 secant u. Either one of these would be fine. Okay. 21, again going back, we have this, so that's going to give me 2 plus tangent squared x minus 1. Down here I get 1 over cosine squared x. A little sloppy there. This changes that to a 1. So I get 1 plus tangent squared x over 1 over cosine squared x. If I go ahead and take my 1 plus tangent squared x multiplied by the reciprocal of the denominator, I get cosine squared x. Remember, tangent is sine squared over cosine squared, so these cosines cancel, so I get plus sine squared x, which ends up equaling Well, I'm going to start over with this one here. Just ran out of room and kind of lost my way, which happens with these kind of trig problems. Sometimes you get going the wrong way here. So I forgot about this minus 1 here. So that was kind of an issue that I had here. So what I'm going to do is I'm going to rewrite the top as secant squared x over secant squared minus 1. And I know that this, well, this is supposed to be tangent. Gosh. Okay, here we go. So far so good here. So I'm going to rewrite this as 1 over secant squared x. This is equal to secant squared, one of our Pythagorean identities, and we have this. Okay, now this becomes 1. 1 minus 1 is 0, so I'm left with this, which the inverse of a secant is cosine. Alrighty. Last one here. Key thing here is that the cosine of negative theta is the same as the cosine of positive theta. And the tangent of negative theta gives me minus tangent of theta. So this cancels this, and so we get cosine theta. Final answer.